Okay, so today we are going to do some environment setup for the coding part of the satellite. We'll be using STM32. So I previously mentioned that I will be using a Raspberry Pi, excuse me, Raspberry Pi and RTEMS, but due to time constraints, we just use something we're familiar with, which is the STM32. You can use free RTOS on STM32. Alright, so I'll show you how to set up the CubeIDE. So I'll just go ahead and start it. STM32 Cube IDE. So it takes a while to open up. And meanwhile, I can show you the chip that we will be using, or the controller that we'll be using. So if I open STM32 black pill, STM32 black pill, this one right here. This is the one that we'll be using. So open image in new tab. Yep. So the black pill uses an STM32F. This can be F. The one I have is F401. F401C CU6 microcontroller. So it's powerful enough for our case. We have all the peripherals we need. We have the power we need. We have a programming interface over here. We have more than enough pins for our use case. UART, SPI, analog, etc. All of that is available. So we'll use this and then we can maybe pivot later, but let's make this basic version work first. So this is the STM32Cube-IDE that I use for STM32 projects. So what we want to do is test whether it is working fine, whether it can compile code, whether it can flash the chip, or whether it can, and any other tool that we need. Just test them out and maybe blink one or two LEDs, and then we'll be fine. So to do that, we come here to File, New STM32 project, initializing target selector. So that takes a few seconds first. So again, you can download this tool from STM32 official website. So this is a target selector window. I don't know whether you can see this small. Yes, it's in small font, but we want to search for STM32 F401 CC U6. This one. So U6, that is the one that we want. Click on next, and then now it asks us for a project name. We want to do a satellite blink test. Satellite blink test. Default location, yes. Which is users PC CubeIDE workspace. Okay. Language C, binary executable. Okay. Next. Leave these ones as they are and click on finish. So just creating the project. Takes a few seconds or so. Okay, so we have a pinout and configuration tool here. This is a UI that is provided for us to be able to configure the pins for STM32. So you can see this chip has well, enough, not very many, but enough number of pins. This is pin 1 right over here where this little notch is. You have the boot pins, and if you click on a pin, you can see the different capabilities or functions that it can serve. So because we want to blink something, we can just maybe select PA8 or let's say PA10 and use it as an output. You will connect an LED here. So GPU output, I normally don't like to have arbitrary names, just like GPIO output. So what I do is I label it to something that I can relate. So you can call it LED. Let's call it test LED. Press enter. That should be just fine. Test LED. If you want another LED, you can put another one. Right click, enter user label. Test. Let's say test. Let's call it user LED. Enter. Right. So for now, that's all we need, but of course you can see other capabilities over here. We'll be using most of them, but for now, let's just run the LEDs. So clock, we don't need any timer configuration. Let's leave it at that at the moment. In the oncoming videos, we'll be configuring a lot of clock parts, but okay. Click on project manager, that is okay. Code generator is also fine. You have to make sure that at this point you have selected copy only the necessary library files to avoid a lot of bloat on the code base. Saves a lot of memory too. Okay, the rest are fine. Tools are okay. All right, so we can generate code because every setting is fine. So if you click save, Control S, you can generate code on that. So STM generates code for you. All right, so you can see that this is our main. Let me close these other files. This is our main C file. I don't know whether you can see that main C file. So one thing that I love about STM32Cube is that it is very powerful, and it does everything you need it to do for you very fast, which is a good thing, of course. But one thing I hate is all of these comments that tell you where to write code. For example, I can write here, but I can't write here. I can write somewhere, I can't write there. So it's really, clouded with, for example, it's clouded with a lot of comments, which is something I hate. So I'd rather use VS Code for this, and I'll show you how to do that in a few minutes. But for now, let's just build this code and see whether it actually builds. So click on build or debug for project, and we watch whether it will successfully build. So right now it's compiling. Finished building, 0 errors and 0 warnings, 11 seconds. Okay, So now I'd rather use VS Code, as I have said. So what you do, you just need to point your entry function to a different function. So you come here to satellite, right click, click new folder. What we'll call the folder, we can call it main application, and press finish. So you can see we have main application at this point. Right click again, inside that folder create another folder, call it SRC. So you can call it source or SRC, but to conform with the convention, you can see that this core folder is as a SRC and include folder. So I'll just name it the same way it's named. You can call it whatever you want, but I'll just remain with the convention. So new folder and SRC, finish. Then in the same folder, which is the main application folder, new folder, another one, we'll call it inc for includes. Finish. All right. So in the core SRC, you can see that's why we have our main. In the include, we have our main.h, or rather the header files. So it's the same folder structure that we are following. So from here, I can open VS Code. So I just search for VS Code. Okay, close these ones. So I'll go to File, New Window. Close this one. File, New Window. Then I open the folder that I just created. Open folder. So it was in. Let me open it on this other side. It was in users, PC, STM32 projects. Workspace. Right, so you can see it here, link. So this is a folder I want, the main application folder. Let's see, let's make this a little bit large. Main application, okay. So select folder. So trust, yes, I trust them. Then in the include, we can create a new file called main.h. Let's call it main app.h. In the SRC also we create main app.c. So obviously the first thing you do here is create the header file. So you can create header guards. You should use header guards here. So if not defined, main app page, define main app page, and if. Right, so main app page is the convention for writing header guards in include files. And we just need one function here, which is the void main, the entry function. So we declare its prototype right there. Save that. And main app.src, what we do in main app.c, we include the header file we just created, which is the main app.c and .h, sorry. Then we create our function void main. Now, what we really want here is this function should take place of the main function that is created automatically by the CubeIDE. So we create our infinite loop here. All right, infinite loop. So basically, this function So you can just have a comment here if you want, but this function should never return. Should never ever return. It's a super loop. So here is you put your main code here. All right. Now, if we go back to the STM32Cube-IDE, you can see now we have. Let's refresh that first. Refresh should be somewhere here. Yeah, refresh. You can see now we have our files main app and main app.c. They are right here. But we need a way of linking the STM32Cube include files with STM32 with VS Code main main.h. This one. We need a way to include this file. So what we do inside our main.h, we include main.h. Okay, minimize that. That's okay. So we can't build this project yet because the CubeIDE does not know where, or does not know that this folder is a part of our compilation path. So to do that, we need to set compilation path for this project to add this folder. So what you do, you come to file, properties, project properties, C++ general here. All right, then you come to paths and symbols. Okay, so includes, you need to add. Click on add. Of course, it's a workspace file, so tick that box. It's a workspace path, and then click on workspace. And then the project is a satellite blink test. Click on this folder, just the folder. That's the one that we want to add to the path. So include main application include folder. Click OK. OK. Apply and close. Oh, I didn't add the SRC. Okay, repeat again. We come here to project properties. In the same C++ general, paths and symbols, you come to source location, comes to just like blink, add folder here. So main app SRC. Okay, apply and close. All right, so let's try building and see whether it will build. So click build right here. All right, so oh yeah, there's a problem. I forgot to have int main. Sorry about that. It's supposed to be int main. The entrant function should be integer. All right, cool. So build. It's okay. So we expect errors, obviously. Main application. Multiple definitions of main. Okay, so there's a function resolution error. So what we do, we rename our custom function, call it. Let's build again. We build that. Okay, so 0 errors and 0 warnings. 0 errors and 0 warnings, which is cool. But now how do we call this function from our main file? So what you do, you come to your main.c, the one that is inside the STM32Cube. And after all these initializations, you want to call your main app function right about somewhere here. You say main app, you evoke the function right there. So what will happen, your STM32 code will enter into this function and then initialize your HAL, your system, whatever initializations you do, and then it comes to this function and it will call this guy right here. And remember, this is an infinite loop, so it will never return from that. So you can easily put your, you can skip everything and put your code right here. Okay, so let's try and build that and see whether it can see the main app. Okay, it can't see it. One warning. Oh yeah, the warning is telling me to include, to include user code. I need to include main app.h right there. Yeah, main app.h. Okay, so build. We want 0 errors and 0 warnings. Okay, warning extra. Okay, 0 errors and 0 warnings. Good. So we are good. So that's how you link STM32Cube with VS Code. So now here we can write our code right there. So next I'm going to show you how to, we just do the blink test and see whether that works. So we are going now to run a blink code here. So to blink an LED in STM32, we need to know which pin is connected to. Remember, we said that we have two LEDs, so we have one that is pin out and configuration here. We have one that is called the test LED, this one. So let's try to blink this one. So when you go to your code, your main.c code, you should be able to see your blink, your LED pin number. So on your right here, you have the GPIO init function. This function tells you the names. So you can see that it's GPIO A, obviously, because we said it's A10, and then the name is test LED pin, right? Test LED pin, GPIO A. All right. So GPIO test LED pin. So we go back to our VS Code. We say that's what we'll be using. So we can use a hardware abstraction library for that. So we can say HAL. Now we should say HAL toggle pin. GPIO toggle pin. What pin do we want to toggle? So the first argument is always the GPIO port, GPIO A. Second one is the pin number. So we call it test LED pin. So let's confirm that first. Yeah, test LED pin GPIO A. Okay. Then we want to delay it for delay. Let's say 100, or let's say 200 milliseconds or ticks. All right. So we save that and build. So we can actually close these files. We can close these ones here. We don't need them. So we'll be using this STM cube just to build and configure the pinout. So we click on build. Yeah, 0 errors and 0 warnings. Okay, so let's try uploading that. So for that we need a programmer. So I use the STM32Cube-Programmer. So I'll open that really quick. STM32Cube-Programmer. So for now, don't bother about the hardware part. We have not really got to that point, but I have a programmer here. I have this STM programmer here. It's connected to a black pill right here. So that's what I'm going to blink. So I'll show you how to do that connection maybe in another video, but for now let's use this programmer. So it's a ST-Link. We need to connect. All right, so once you click on connect, you can see it has connected to the target, or rather to the black pill. Now to program, you click on erasing and programming. You have to choose your X file, rather ELF file, ELF, hex. I call it hex. There are two different files, but whatever, they are the same. So our folder was located on the. So I'll just open that real quick here. Users. See STM32Cube-IDE workspace. Cube. STM32Cube-IDE workspace. This is like blink test. So you can see this is a project. You go to debug, you find the ELF file here. That's what you open, and then make sure you have pressed run after programming and a full chip erase. Then click on start programming. All right, so you can see start operation achieved. Okay, then file download is complete. So I'll show you how that looks like. So I'll just connect an LED to pin 10 here really quick. I'll show you the running part, or rather that it is able to compile and run. So that's the LED, which means that our project is set up and ready to go. So we can proceed with writing the code and the files and the drivers and anything we need for this project. So the beauty of VS Code is that it's pretty to look at. There's no bloat and anything like that, so we can focus on the code itself instead of focusing on avoiding comments and looking at where we should write or not write code. It's just too much hassle. So okay, so if you have any questions, just shoot me in the comments, and see you next time.